Hello class, today we're going to talk about section 4.5, which covers scatter plot and lines of fit. By the end of today's lesson, you'll be able to identify the different types of correlation and explain those relationships, and then determine the line of best fit for a particular scatter plot and use that line to make predictions. So first off, a scatter plot is a graph that shows the relationship between two data sets. So for example, age and height, or temperature and number of ice cream cones purchases, or number of trees in your backyard and number of people living in your house. So it just has to be two different sets of numerical data. The data is graphed as ordered pairs, and the purpose of scatter plots is to investigate if or how data is related and then to find those patterns. The line of fit, or sometimes called the line of best fit, is a central line that goes through all of the data points and is as close to touching those points as possible. It may not actually touch any of the points that you graph, and that is fine. It just has to go through the center of all of those data points. Then there are two types of prediction: linear interpolation and linear extrapolation. Linear interpolation is making predictions from inside of the data range. So if you are looking at the height of people from ages 1 to 10, making a prediction for someone at age 7 would be interpolation, because 7 is between 1 and 10. Linear extrapolation is making a prediction outside of the data that you have. So again, if you're looking at ages 1 to 10 and comparing those to height, making a prediction for someone at the age of 15 would be extrapolation, because you are going outside of your highest data point, which was age 10. There are three types of relationships that we have for scatter plots. There is a positive correlation, which means that as our x values get bigger, so as we move from left to right, our y values also get bigger. So our y values are also increasing. And that is shown on this first scatter plot example. X is getting bigger and our points are going up. The next type of correlation that we have is a negative correlation. That means as X is still getting bigger, so we are still looking at our X points moving from left to right, our Y values are getting smaller. So as you move from left to right on the graph, your Y values are going down. The last one is looking at our X values once again, getting bigger, moving from left to right on the graph, and our Y values have no particular pattern. Sometimes it seems to go up, sometimes it seems to go down, or there might not be any relationship at all. You might not even be able to find a general trend. So we're looking at those three different types of relationships. Looking at our correlation, this first example, average time spent watching TV in a week and the average size of a television. So your job would be to look at this graph and say, is there any relationship between these two factors? Could I draw in a line that makes it go up? That's not very close to all of our data points, so it can't be positive. Same thing, could I draw a line that goes down? Again, that doesn't really fit this data very well, so it's not negative either, which means this particular graph is no correlation. Your book is going to ask you to explain this, so what you're going to want to say is, as the time spent watching TV increases, there is no effect on the size of TV. So you want to say what's happening to X. Remember, in every case, X is increasing. And then say what happens to the Y as a result. There's no effect on the size of television. Looking at this second example, we're comparing year to the number of travelers in thousands. So the first thing we want to check is it going up? If we're looking at this set of data, yes it is. So we would call this a positive correlation, and we would say that as time increases, so does the number of travelers. Again, notice I'm not getting super specific with these explanations, but I am making sure to include the label from the x-axis and the label from the y-axis. Go ahead and try this one on your own, making a prediction about the correlation and an explanation. This is a negative relationship. The higher the average grade, the less time spent watching TV. The other thing that we're going to do in this lesson is making a line of fit. The first job that you have is to make a scatter plot and determine if there is a relationship. If there's not a relationship between the data, then you're done. You can't make a prediction if there is no relationship. If there is a positive or negative relationship, you're going to draw a line that seems to pass close through the center of all of the data points. Once you have that line, you're going to pick out 2 points on the line and write an equation for that. And then you're going to use that equation to make predictions. When you are writing your equations, this should be in slope-intercept form. So y equals mx plus b format. So we're given this data showing the table, or data is shown in the table that compares the years since 88 and compares it to the vertical drop in roller coasters. So your first job would be to make a scatter plot. We're looking at numbers 1 through 15. The scatter plot you are provided with has 15 spaces going across. So on the x, you're going to be okay to just number 1 through 15. On the y, our smallest number starts at 150. So we aren't going to want to start at 0, or we aren't going to want to start at 0 on our graph. So as you can see, what I've done here is I started at 150. Notice right here, I put this little squiggle line. That's to say that I'm skipping a bunch of values so that I can start at 150. From there, I chose to go up by 20s, getting me up to 430. I graphed all of my data points, and that is what those red dots are. So that takes care of step 1. And then we need to decide the relationship. There seems to be a general trend going up, so it is positive, so we are going to finish the rest of the problem. Our next step is to draw in a line so that we can predict our general trend. Again, we want it to go roughly through the center of all of our data points. So I'm going to start here and go roughly through the center of all of my data points. We would not want to draw in a line going like this. That is far too steep for our data. Or we would not want a line going here. That is too flat for our set of data. Our one point up here is kind of far away from everything else, so while you are drawing that line, you can kind of go ahead and ignore that. Alright, so now that we have our line drawn in, we're going to want to continue this process of finding the line of best fit. So that means we need to pick out 2 points that are on that line that we drew. So 2 points on the line that we drew. I'm going to go ahead and pick out 10, 250, and 13, 290. Those are 2 points where I can say exactly that they run into values. You wouldn't want to pick one of these middle points right here, because while you can tell that it's at 11, we would have to guess about the y value, and we want to eliminate as much guesswork as possible. This being said, my line of best fit might be in a little bit of a different spot than your line of best fit that I just talked about. So I'm going to continue using this line that I have. If you want to follow along with me, that's fine. If you want to try following along with your own line that you drew in, you can do that as well. So my 2 points that I'm using are 10 to 90 and 10 to 50 and 13 to 90. So now I'm going to use those 2 points to find slope using the slope-intercept equation. So I have 290 for y2 minus 250 for y1 over 13 minus 10, which gives me 40 over 3. 40 over 3 is kind of a difficult slope to work with. For this lesson only, it is okay to turn your slope into a decimal. So when you are working with scatter plots, it is completely fine to turn your slope into a decimal. So when I convert 40 divided by 3 into a decimal, I end up with 13.33. Make sure that you are using 2 decimal places. So as I continue this problem, I have my slope now, and I am going to turn this into a linear equation. So I'm going to use point slope format because that's the one that I prefer, but you can use slope intercept as well. So y minus y1, which is 250, is equal to my slope of 13.33 times x minus x1. Again, we want to get rid of those parentheses, so our first step is to use the distributive property, which gives me y is equal to y minus 250 is equal to 13.33x minus 133.3. I'm going to finish up by adding 250 to both sides of my equation, giving me a final answer of y is equal to 13.33x plus 116.7. So that is my equation for that line of best fit that I drew into the graph. The last thing that this problem asks us to do is to predict the vertical drop of a roller coaster built 25 years after 1988. So now that we have our equation, we can go ahead and solve this problem by plugging in 25 as our x value. So y is equal to 13.33 times 25 plus 116.7. When I do use PEMDAS to solve this equation, I get 449.95, and I want to make sure I put that label on there of feet. If you were doing this using your own line as we were following along, your answer should be somewhere close to 449 or somewhere close to 450 because everybody has their own lines. When we do this in class, everyone's answers will vary slightly, but it should be close to that answer. So here's another example of a scatter plot that has already been drawn for you. It also has a line of best fit drawn in. You can see based on the line that it is a negative relationship between the temperature and the amount of hot chocolate sold. So what we want you to do here is use that line, including the 2 points that are already given to you, to find the equation for that line of best fit and then predict the number of hot chocolates sold if it is 40 degrees. So your equation should have been y is equal to negative 0.05x plus 7, and your answer should have been 5 hot chocolates at 40 degrees. If you have questions about this or anything else from the lesson, please let me know when you get to class.